Solving systems by graphing. Now again, this should be a lot of review from last year. Yes, we're going to increase the level of challenge just a bit, but the basics are the same. To solve by graphing, first, graph all the equations. Second, look for the point of intersection. Third, state your answer as an ordered pair when possible. Now, when it's not possible, I'll give you an idea of what to do, but we're basically going to label that it's a fraction solution in a particular quadrant, so that way I know that you're in the right direction. So we want to solve by graphing. Couple of things we should be remembering. Y equals mx plus b is our preferred format, where m is our slope. We talked about this last week. B is our y-intercept. So we have a slope and we have a y-intercept. Now the y-intercept basically means, hey, this is where it intersects the y-axis. So this particular one intercepts at -1. And the slope, that's our rise over run. So remember, we can take any slope, even if it's a whole number, and turn it into a fraction. And lo and behold, we have a rise over a run. So I'm going to rise 2, run forward 1. I'll rise 2 more, run forward 1 more. Rise 2 more, run forward 1 more. Now, I would prefer it if you used a ruler to make sure that your ordered pairs connect in one solid straight line, but since I'm using a tablet and doesn't always happen that way, obviously my line is not going to be perfectly straight. I do want to see arrows on both ends of the line that signify that the line is going on and on forever. All right, next equation. Y is equal to -1/2 x minus 6. So again, I have my y-intercept, which is my b value. I have my slope, which is -1/2. Well, you're welcome to keep the negative sign out in front. I always tell students to write it this way, -1/2, because that's now going to tell me my rise is a -1, in other words, going down, and my run is going forward still. So let's get our y-intercept is here, and we are going down 1, forward 2. Well, I can't go down anymore, but if I went down 1 and forward 2, that's the same as going up 1 and back 2. Up 1 and back 2. And so we can see that our line is going to end up right over here, and it will go on and on forever. Now the question of the day, what is the solution to the system? Now I see right here, it intersects perfectly with the x equals 2 equation and the y equals 5 equation. And so that's my ordered pair where the solution is. And we're done with the problem. Graph each system of solutions, then determine which category each system will fall into. Now, I'm going to give you just a second to graph these on a separate sheet of paper, and then we're going to talk about which solution they will fall into. Press pause on the video to graph. All right, welcome back. Now, you should notice that this is a good bit of review from yesterday because we talked about one solution, no solution, infinite solution. So you really didn't even have to graph these because we also discussed when the slope is the same. In other words, if I have two lines, they have the same slope, they're going the same direction, they will never touch each other. But it has different y-intercepts. They are parallel. Now tell me when any two parallel lines are ever going to touch. They won't. They will always be parallel to each other. So they will have no solution. All right, let's get these in slope-intercept form so I can see what's happening. So minus x 3y equals -x plus 6 divided by 3y is equal to -1/3 x plus 2. Wait, that looks familiar. Those are both the exact same equation. Well, anytime we have the exact same equation, I have a graph and one line with the second line right on top of it. Well, that's going to be an infinite number of solutions or all real solutions? All right, next up. Y equals 2x minus 1, y equals negative 1/2 x minus 1. Now, these have different slopes. But not only do they have different slopes, I have a y equals 2x and I have a y equals negative 1/2. We should see a very special relationship between these two. Yeah, that's right. They are inverses of each other. More than just inverse, they're opposite inverses of each other. And since they are opposite inverses of each other, they are perpendicular and will form a right angle to each other. Regardless, we end up with one solution. Our key focus on one solution equations were having different slopes. Quick inequality review. When you flip the inequality statement, you flip the entire sign with it. So, we subtract x from both sides. 4 is greater than 4x. I divide by 4. 1 is greater than x, but I don't want the x on the right side. I don't want any final answer with your variable on the right side for an inequality. So I'm going to flip the entire statement. X is less than 1. That's our solution. When you multiply or divide by a negative number, so notice I need to first subtract 4 from both sides. 14 minus 4 is 10 is less than negative 2x. And I need to divide by negative 2 on both sides of the equation. When I divide or multiply both sides of an equation by a negative, it causes the sign to flip. So we have negative 5 is greater than x. Notice this particular problem has the variable on the right side, so what am I going to have to do? That's right, I've already flipped the sign once. I'm going to have to flip it again so that I can invert the statement. So now x is less than or equal to negative 5. Remember, you can check any solution here. I can take a value like negative 10 and plug it in. Negative 10 times negative 2. Well, that's positive 20 plus 4 is 24. Is that greater than 14? Sure it is. Symbols. Greater than and greater than or equal to mean to shade above. So when you have the y equals negative 2x plus 4 and you graph it, you will end up with an equation that looks something like that. This symbol, I made a solid line, so we'll go ahead and make it that way, means that we're going to shade up here. We're going to shade above it. Shade below. Now, same deal. When I have an equation, y is less than negative x. We'll just do that. Then we graph the line, and we are shading below, so everything underneath it. All right, greater than and less than, so we're going to have dashed lines. Greater than or equal to, less than or equal to, we're going to have solid lines. So let's give one of an example. I'm going to go ahead and start with, I'm not sure why I have an extra mark in there. Let's go ahead and simplify this to get y equals. So we want to add 2x to both sides. Negative y is less than or equal to 2x plus 6. And we're going to divide by negative y, negative 1. So that'll give us y is greater than or equal to negative 2x minus 6. All right, so let's come down to -6 because that's our intercept. And our slope is -2 over 1, so we want to come back to up 1. Back. All right. Up 2, back 1, up 2, back 1, up 2, back 1, up 2, back 1. And so this is what the line is looking like. We have a greater than or equals to, which means I need a solid line connecting these. All right, now my next equation, let's go ahead and just graph y equals positive 3x. I don't know why that looks so funny. So y is less than 3x. Intercept is going to be 0. We go up 3 over 1, up 3 over 1, down 3, back 1, down 3, back 1. Remember, I need a dotted line. And now I need to figure out where I'm shading. So on my second equation, we want everything less than or below. So we're looking here, below. On my first equation, I want y is greater than or equal to, so everything above. So the solution we're ending up with is everything in this area here. Oh, let's try another. Well, this one has now 3 inequalities. So y equals x minus 2. I want to find our y-intercept. And we're going to have a positive 1 over 1 slope. Up 1 over 1, up 1 over 1. Up 1 over 1, up 1 over 1. We want a dotted line connecting these. All right. And then we want everything greater than. So for right now, I'm just going to make a little mark here so I know which direction we're shading on that particular line. Y is less than or equal to negative 2x plus 3. So I want my y-intercept. I want to go down 2 over 1, down 2 over 1, and we can see the pattern of the line. Again, we said it was going to be a solid line. Please use a ruler for these so that your lines are much more clearer than mine. We want everything less than. Now, this is our second inequality. It needs to be above the dotted line, but less than the solid line. So I'm going to come put a mark right here. Next equation, x is greater than negative 3. Well, if we have x is greater than negative 3, that's just like saying x is equal to negative 3. That's an x equals equation, which is vertical. So we want to find x at negative 3, and it's going to be a greater than sign, which means a dotted line. Vertical at x equals negative 3. And we want greater than. Well, what's greater? Greater is talking about this number line if we're talking about just x values. So everything to the right of it. And now notice that we end up with what appears to be a triangular shape that gets shaded in right there.